Welcome back to our special series on electromagnetism. In this segment, we'll delve into advanced electromagnetic concepts, focusing on beamforming and phased arrays. Joining me are our experts, Brian and Ruth, who will explain how these technologies work and their benefits in telecommunications and defense. Brian, let's start with you. Can you introduce us to beamforming technology and explain how it works?
Certainly, Matthew. Beamforming is a technique used to direct the transmission or reception of signals in specific directions using an array of antennas, known as a phased array. This is achieved by adjusting the relative phases of the signals transmitted or received by each antenna element in the array. By doing so, the radiated power can be focused in desired directions, enhancing signal quality and coverage without physically moving the antennas.
Ruth, can you explain how phased arrays work and some of their applications?
Phased arrays consist of multiple individual antenna elements arranged in configurations such as linear, planar, or circular arrays. Each element has a phase shifter that adjusts the phase of the signal it transmits or receives. By controlling these phase shifts, the array can electronically steer the direction of the main beam. Phased arrays are used in various applications, including radar, telecommunications, satellite communications, and wireless networks. They enable dynamic beam steering, improving signal quality, coverage, and capacity.
Brian, could you elaborate on the benefits of beamforming in telecommunications and defense?
Certainly. In telecommunications, beamforming enhances signal quality and capacity by focusing the signal toward specific users or areas, reducing interference, and improving overall network efficiency. This is particularly useful in wireless networks, where it helps manage the increasing demand for data and connectivity. In defense, beamforming and phased arrays are crucial for radar systems. They provide precise targeting, tracking, and detection capabilities, allowing for better situational awareness and response. Additionally, adaptive beamforming algorithms can dynamically adjust the signal based on real-time feedback, improving performance in changing conditions, such as mobile communications or jamming scenarios.
Thank you, Brian and Ruth, for explaining the intricacies of beamforming and phased arrays. In our next segment, we'll explore the use of beamforming and phased arrays for 3D positioning, discussing real-world applications and theoretical possibilities. Stay tuned as we continue to uncover the wonders of electromagnetism.